Hi guys, today we will derive the time independent Schrodinger equation from the classical wave equation. As we know, this is the classical plane wave equation. Here psi represents the displacement of the wave from its equilibrium position, and A is the amplitude of the wave, and K is the wave vector of the wave, and omega is the angular frequency of the wave. Differentiating this equation twice with respect to position gives the first derivative brings out ik from here, and second derivative brings one more ik and it become I squared k squared. We know I squared is equal to minus 1, and this factor here is nothing but the original psi that we took. So substituting these two into equation 3, we get this equation, and altering this equation we get fifth equation. And we know wave vector can be represented in terms of the lambda as this way, and substituting this into equation 5 we get equation 6 as this. And we know from the de Broglie hypothesis that the wavelength of the microscopic particle can be found if we know its momentum as this using this equation. Lambda is equal to h by mv, and substituting that into equation 7 gives this equation. So here we can see mv squared is sitting here. This is nothing but p squared, momentum squared, and momentum squared from the classical mechanics we can write it as 2m times the kinetic energy. And for any conservative system in which energy is equal to k, kinetic energy, total energy is equal to kinetic energy plus potential energy. And for kinetic energy, altering this equation gives E minus V, and substituting that into here gives the momentum squared as 2m times E minus V, and putting equation 10 into equation 9 gives me this equation, and altering this equation gives the time independent Schrodinger equation in two different form. Both are same only. So this is called time independent Schrodinger equation. That's